Hi, I have this contraption to basically manage the boiler heating because in the winter I am burning wood and I have some excess hot water, and so I was like, okay, so I can have free hot water, quote unquote, with this heat exchanger, but I want to somehow control how it works, because obviously you don't want to have situation when you have a boiler heated up to 60 degrees, then suddenly you start pumping the water through the boiler through the exchanger when you start heating your house. Basically, all the energy from the boiler will discharge to your heating, but something overall is unnecessary. So anyway, I also have some for photo circulation, so again, I have still seat. This thing is based on Arduino, and the cheap OLED display, you can see that it is already burnt out quite badly. And so I wanted to also replace the OLED display. So I've started designing, and this is roughly a thing that I came up with. It has 4 outputs and a bunch of GPIOs here. 4 digital and analog IOs, multiplex. This is PWM output, and there is some UART and I2C communication, also multiplexed with IOs. Like there are these 2 standoffs glued onto the components, which is not ideal. I probably will have to redesign this slightly for like version 2, because I will probably need more of these in future. I could have made these bigger so they can carry more current and unmask them so I can thin them, but instead I fucking did this. So anyway, there is not much on the low voltage side. There are 4 N-channel transistors and diodes, and that's about it. For the control, I have chosen Raspberry Pi because it's very convenient to type SSH something into the terminal and have complete control over the device, assuming that I don't fuck up the antenna here. So anyway, there are some transistors for pull-ups on the analog ports and some I2C analog AD converter. Nothing else here really. There is header for keyboard, which is not integrated at this moment, but I have realized that I fucked up, and this header should have been moved as close as possible to the Raspberry Pi, because if you look at how this works, it is basically like there is not too much space in the topmost section. For the display, I have chosen this one, TFT color display. There is just glued something to basically make it flush, kinda sorta. So yeah, this is just put on here like this. There are some things I would like to change for future revisions. For example, the keyboard, I was thinking, okay, we'll have 4 keys, like up, down, left, right, and that would be enough for basic user interface. Then I was thinking, well, actually, like having a rotary encoder would be much nicer. And for rotary encoder, you really want to connect to I2C bus and have a like dedicated microcontroller for it. Something really tiny. I'm not sure what I would do for it, but this could be integrated on this board easily, so I would probably do that. I am expecting analog inputs to be very questionable, and I mean, these are questionable even with the Arduino like thing there. There is a lot of noise, especially if the water pump is running like the main pump that pumps the water from the well to the house, because it is behind VFD, so that is generating a lot of noise. Then obviously like some mounting holes, something different than random offcuts of polycarbonate that I have found. This I have 3D printed with the intention of like screwing this in. Yeah, also I have made this board. I expected to have much longer interconnect, but actually this is fine. There is a hole, so I could screw this in. Maybe I should, I don't know. But anyway, this is relatively stable. I mean, sure, the display wobbles a little bit, but like this board is stable, so this is pretty good, I would say. Then these are 10 amp relays, which explains why I had to reinforce these tracks. I don't expect each relay to be running at 10 amps, but the idea is that there will be 16 amp circuit breaker before this module anyway, so 16 amps would be like fine, and these fuses protect just the relays, so I think these are slow fuses, so it is more likely that the breaker pops before the fuse like blows, and which is questionable because I mean these are 10 amp relays, so what am I doing? I think slow fuses are fine for these relays. It's probably somewhere in the documentation, but I did not read it. Then this is the case I'm using. I had to modify it slightly. Well, I had to cut out a bunch of stuff from the inside. There are like a lot of tiny stuff that I don't really understand what are they doing, but anyway, I did had to clean it up. This is a little spacer because it turns out that I have made this board a little bit too short, but it's fine. And finally, this is a 0.5mm FR4. I have applied silkscreen, white silkscreen paint to the top and cured it all, so it looks okay. I had to mill this side because this is original, it is curved, so like why are you making this curved? I guess the idea is that thing will be like pushed into it, not glued on top of it, but anyway. I was also thinking about making these 4 modules. This is more convenient form factor even, but I have decided against it. I guess most convenient about this is that it has a cover that goes on top. This doesn't have one. Oh yeah, the display connection. I had to glue in pins to this connector, like they are literally glued in, because I did not think about how this is going to go together, but it goes together quite nicely this way. Speaking of going together, I guess let's put this together. These are standard wood screws, just cut off a little bit because where would you get screws that go into plastic? Then you need to attach connector to this assembly and put it here, yeah, this way. Well, I also had a oopsie here. Turns out that I need to make a small cutout here, but there was a trick, so anyway, basically this registers with this pin just barely. Mostly this board lies on top of these 2 things, and yeah, I can show you, I guess. Yep, and it is in. Somehow this just happened to like work. Like the display is perfectly like flush. It goes together like this, and it kinda sorta happens to match the height of all the components that I have used. I did not plan for this to happen. Anyway, so now you need to connect these 2 parts together. You need to kinda sorta align the pin header there. I mean, it's not really easy to see, but like if you do this, it should go together, and yeah, it is together. Good idea would be to have different color for these terminals, because like it can happen that you plug 230 volts to this one, but yeah, that would be bad day. Probably the best thing I can do is have a very thin PCB that can be glued here, and with silkscreen marking what the terminal is used for. And I think that's a pretty good idea actually, because I have grounds here like marked. It's just the permanent marker, so it can be removed easily with solvents. Okay, so let's power this one on. Even though these are spring-loaded terminals, I don't really like this for some reason. Like, yeah, this is fine, but it's like, they are not so great. Yeah, somehow I wanted this to be neutral, but then I realized I'm stupid. So So I've configured this to use frame buffer. The downside of this being Raspberry Pi is of course that it is slow to boot. So far I don't have really much for demo. I mean, I have built a kinda sorta, well, I have used AI to make me smallish framework based on Python that can support basically what you want for PLC, or in this case HMI. So basically you can draw background and you can draw a bunch of elements and text. So these elements can be like custom, so you can have like, I don't know, well, anything really. Then this is decoupled from the sensors reading their values and the PLC doing its logic thing. So this is just a random example. This rotating cube is custom element that is positioned somewhere on the screen and it is animated, which is one thing I wanted to support. And yeah, there is some simulated stuff here, some simulated UI elements, some text, and the FPS seems to be really good. There is some tearing on the display. This is probably because this does not have double buffering, even though I think I've enabled it, but it's like the display driver, like, I don't know, I don't know, I don't care even. Now it is a bit unfortunate that this front panel is glued on, because if it wasn't, you would be able to see that there is not much space here. There's about space for my finger, not even that. And so you could put in a rotary encoder here. So like the keyboard stuff, like, yeah, you could have keys in a row, but other than that, not really. So rotary encoder would be good because you can also click, and so that would be really nice. So I have this rotary encoder here. It just barely fits there, and even so I had to modify these legs, bend them inwards, because otherwise they would collide with the LCD a little tiny bit. But still, this is not designed to be panel mounted, and I would like this to be panel mounted because now I am thinking about this a little bit more, and the manual control is good for one thing. Like, let's imagine that you want to, I don't know, test something or prime some pump, so you basically scroll to the pump manual control and then press and stop the button with your hands while looking at the thing that it is controlling. So, but like, it's already 2023, it is easy enough for this to have a web server, and that way you can have your phone and click the button, and you don't even have to stand next to this unit physically. So you can have some device like 15 meters from this thing, and you can do the thing. That sounds actually pretty good to me. Yeah. So I did some programming, I draw some basic UI for this, and right now this is doing nothing else, just control this one pump based on the exchanger temperature and, well, other stuff too, but anyway. This basically works exactly the same as the, I don't know, 2 modules stuff that I have there. So I will need to add some code for this pump and maybe something else in the future. But right now I just need this to replace the functionality that I have already there. I found some minor issues. I have realized that these outputs are pulled up high by default because I forgot to add pull-ups to my pull-up transistors, but anyway, I have changed the schematic, so at least these 5 ports should be like pulled low. The UART, you have no control about that, and the I2C, I mean, that is also pulled up. I mean, I could have added another like external pull-ups, but like anyway, so I guess let's install this and see what happens. Alright, so this is how the installation looks like now. Nothing really special. I mean, there is this wire jungle down there, so I hope that I will be able to remove a bunch of these, but other than that, I guess the most important is the analog connection up there, so yeah, that's about it, I guess. Okay, so the box is installed. Idea was nice, but reality is not as much. So first of all, I have realized that okay, I need a 16 amp breaker here because master on-off switch. Then I need a 6 amp breaker here because this VFD, while it is connected via 1.5mm copper wire, the wire that goes to the pump is, I think, 0.75mm. So I don't know, I calculated it before. It is definitely good for 6 amps. So that's that. Second thing is, I had a nice bus bar here. Now I have this ugly Wago interconnect, and there is this wire going all the way to phase input here. So not great. So for future, consider having phase input here. However, this is low voltage I/O, so I don't know, maybe this is what I will have to live with. Then, kinda sorta quote-unquote problem number 3 is putting wires in these terminals is not as easy as putting them into the screw terminals. So maybe just find better screw terminals, I guess. I don't know. Like, it is definitely going to be problematic because in this dimension, like, yeah, go ahead and find some. So 2.5mm copper, it was fine, but anything else would be problematic. Also, this is not solid wire, this is like cord, I guess you can call it. I tried to use ferrules. I was not able to put them in, but probably I just wasn't trying hard enough because these ferrules are... What the fuck does that mean? I have no idea. Anyway, the analog part went in quite well. I did not have to use any tools. Here I had to use pliers to like force them in because otherwise I would have no chance doing this. Anyway, so let me, I guess, turn this on and I will go turn on power to this box. Hopefully this works well. Okay, no fire so far. Okay, so I've put the cover on because at this point there is not much else to do. I think any bugs I will fix in software, and I think there will be something to fix because if you look at this, the values are not very stable, are they? Okay, so this was quite quick. Turns out this was a bug in the code, in the configuration of ADC somehow. I don't know, I did not write the code, I used LLM again, and so as usual it does it well on the second try. So this is now fixed. However, I want to see how much noise do I introduce when the VFD is running. So let me open this valve. Oh my god, this is not great. Maybe I will try to stabilize this footage. Oh yeah, there is a bunch of noise introduced now. I don't think it's as horrible as it was before. I'm not going to shield this, this is fine. It's just when the temperature in the exchanger is at the threshold and I run the water, it like blinks the pump on and off. But I have added some hysteresis to the exchanger pump too, so this wouldn't happen. But also I could add some low pass filter in the software, so that should do the thing too. It is looking much better in person than on camera, and now I have opened the door, so even still the backlight that is leaking through the panel is quite more on the camera, and the readability is also quite better in person. So the best I can do on camera is this, and it still looks much better in person. Anyway, so that's it from me, and see you sometimes in future.